morning. So today we're going to start to look at circle theorems. We finished with the triangle theorems, and do let me know if there's any part of that that you don't understand. So to begin with, we're going to just remind ourselves of some definitions which I'd hope you'd know from Junior Cert, but just in case. These are certain lines that are involved in circles and we do need to know them. So of course, the first one, diameter, I'm sure you all know from primary school. The diameter is the line through the center of a circle joining 2 points on the circumference. And the circumference, of course, is the outside of the circle. Just move this slightly. Sorry about my bad spelling or my bad handwriting. So a quick little diagram here to remind us. If we have a circle, there's the center, the diameter can join one point on a circle to another point directly across, and it must go through the center. If it doesn't go through the center, it's not the diameter. Following on from the diameter, of course, we have the radius, and the radius is half the diameter, is the way we usually think of it. Half the diameter. It's a line joining the center of the circle to a single point, to one point on the circumference. So again, a little diagram to go with that. Let's put a small circle over here. And once we know the center, we can draw the radius to any point on the circumference of the circle, like that. So the radius again must go through the center of the circle. Right, after that we have something that's called a chord. So a chord is a line that intersects any 2 points on the circumference of the circle. Now, a chord doesn't necessarily go through the center, but it can. And when it goes through the center, it's a diameter. So a diameter is a special case of a chord. So it doesn't necessarily go through the center. But the diameter is a chord, is a type of chord. It's a special case of a chord. Let's look at a diagram of a chord. So, but usually when we have a chord, we don't consider it going through the center. We pick 2 other points on the circumference of the circle, like this, and we do a line joining those. Okay, so a chord kind of slices off a bit of the circle, but not half of the circle. Okay, the final type of line that we want to discuss in relation to circles is called a tangent. And a tangent is a line that only goes through one point on the circumference. So we think of a tangent as touching the circle. touching the circle at one point only. Now, and it looks a bit like this. We have a circle. So of course it doesn't go through the center either, unlike the radius. So a radius is not a tangent. I know it's kind of going through one point there, but if I continued the radius, it would go through 2 points. So a tangent then is only going to touch my circle at one point, and it looks like this. That's not a very good diagram. But a tangent is, if you imagine a ball sitting on a surface, that's what a tangent is like. The surface would be a tangent to the circle. Okay, so why did we need to know all of these terms? Well, we have a few theorems that we need to know the definitions of and know how to use. So we've got several circle theorems, and we're going to write down the definitions of 3 of them today. It doesn't matter what numbers are applied. I'm going to give them a shorthand name, but you don't need to know the name. You just need to know the statement of them and how to use them in an example. So we're going to look at 3 circle theorems today. Okay, the first one, I think of this one as my right angle on a diameter. And the easiest way to remember your circle theorems is through a diagram. So each of these will have a diagram associated with them. If I draw a circle like this, so right angle on a diameter. If I draw in my diameter of my circle going through the center like this, you don't have to use a ruler to do this. You can just do it quickly. What this theorem says is that if I have the diameter of a circle and I pick any point on the circumference of the circle, any point at all, and I join that point to the end points of my diameter, like this, it will always make a right-angled triangle. Now, how do I state that? The statement of this theorem says that the angle created between any point on a circle, on its circumference if you want to be technical, but on a circle is fine, standing on the diameter of that circle makes a right angle. Okay, and you might not believe me that it doesn't matter what point I pick. Okay, so I can pick a point directly above it like this. And I hope you can see that's going to make a right angle. I can pick a point, oh sorry, of course I don't join it to the center. I join it to the 2 points like this. I should just scribble that out. Sorry, that was my mistake there. That's going to make a right angle. If I pick a point all the way over here, even really, really close to one of the other end points, it will make a right angled triangle, always. So all of those will always make a right angled triangle, regardless of what point I pick. So that's the first circle theorem that we need to know. The second circle theorem is about chords. So if you join, that's the statement of it, let's say the midpoint of a chord and the center. So this is my kind of shorthand name for the theorem that we want to remember. So just remember that you're talking about the halfway point of a chord and the center of the circle. So a chord doesn't usually go through the center. I pick any 2 points here like this. And the midpoint of those joined to the center will always make a right angle. So this theorem says, the statement of this theorem says that the line joining the midpoint, so make sure this stays on my screen, the line joining the midpoint of a chord to the center of the circle always makes a right angle. And we should note the converse of this theorem is also true. So what does that mean? That means that if a line from the center to a chord makes a right angle, then it bisects. It's joined to the midpoint. It bisects the chord. It cuts it into 2 equal halves. So that's why I put in these marks here to say that it's cutting it into 2 equal halves. Okay, and let's write down our third theorem. And the third theorem is about tangents. So tangent and the radius. And this is something that you'll have come across if you were doing higher level when you learned coordinate geometry of the circle. So the diagram, draw in a quick circle, we'll pop in a tangent like this, and the center. Whenever you have a tangent at a point and the center of the circle, the radius and the tangent will always make a right angle. They will always make right angles. So the statement there of that theorem is that the radius of a circle and the tangent, any tangent to the circle, are always perpendicular. At the point where the tangent touches the circle. The point where the tangent touches the circle. And the converse of that is true as well. So the converse is true, which means that the perpendicular distance from a tangent to the centre is equal to the radius. So if I make a perpendicular line from my tangent to the centre, that will always be the radius, has to be. Okay, so how do we use these then? Well, we're going to go through a good few examples of them tomorrow. I must just add in, I forgot to state that the converse of the first one is true. The converse is true, which means that if you have a right angle triangle, in a circle, the hypotenuse, the longest side, will be the diameter. Okay, so if I draw any circle and it makes a right angle up here, I know that the longest side there must be a diameter by the converse of this theorem. So mostly tonight, I just want you to learn the definitions of those theorems, but I do want you to try a couple of questions. And you might do them in class time if you have the time. And it will be page 322, questions 1 and 2. And in the new book, that's page 341. And I'll put those up on Google Classroom as well. So try your best with those. Okay, and you might let me know if at any point the work is taking more time than you have to do it during the day as well. Okay, thank you.